Okay, got a request for number 9 from 1.2. This is the limit as x goes to infinity of 1 minus the cosine x over x squared. We want to find this limit graphically and confirm our answer with the squeeze theorem. So first, let's head over to Desmos and graph this function. So I'm going to call it g. And let's say 1 minus cosine x over x squared. There's the function. We want to know what the limit is as x goes to infinity. It appears to be 0 as we go further and further and further and further to the right. Yeah, nothing weird. So that's what we should say initially is our answer, 0. And let's confirm it with the squeeze theorem. So I want to begin with the idea that cosine x lives between 1 and -1 always. This is not necessarily just cosine x, it's got 1 minus. So let's go through the process of changing this so that the function in the middle of the triple inequality is 1 minus cosine x. So the first thing we'd want to do then is multiply everything by -1. So -1 times, -1 times, -1 times. So that's going to be 1. We multiply by a negative. Obviously, the inequalities flip. And then this becomes -1 over here. Let's rewrite that inequality so that it's -1 is less than negative cosine x, which is less than or equal to 1. And then 1 minus cosine. So let's add a 1 to each piece. So this becomes 0 is less than or equal to 1 minus cosine x is less than or equal to 2. And then let's not forget about the denominator, divide by an x squared. So divided by x squared, divided by x squared, divided by x squared. And it looks to me like we have 0 is less than 1 minus the cosine of x over x squared. And that's less than or equal to 2 over x squared. So what we've done then is squeezed our function, 1 minus cosine of x over x squared, in between f of x equals 0 and h of x equals 2 over x squared. So let's see if those two functions really do squeeze our function by taking a look at the graph again in Desmos. So let's go f of x equal to 0, and let's go h of x equal to, what do we have? We have 2 over x squared. 2 over x squared. All right, so let's go and zoom in a little bit. And yeah, our function is between f and g. And as we move further and further to the right, it stays between, it's bounded between the two of them. It oscillates a little bit, but it always stays above 0 and below 2 over x squared. So since the limit as x goes to infinity of 0 is the same as the limit as x goes to infinity of 2 over x squared, and those are both 0, we can say for sure the limit as x goes to infinity of 1 minus the cosine of x over x squared is indeed 0. And that's how we prove it with the squeeze theorem. Hope that helps.